Hi everyone, welcome to Coadep Econs Academy. This is where you sharpen your skills before exams. Today, we are going to focus on basic calculus. In our study of economics, one of the most important mathematical tools we are going to employ is calculus. And today we're looking at differentiation. We want to derive the power rule of differentiation from the first principles. The lesson is going to be interesting. You're going to understand what differentiation is all about and why we are using certain rules that we are using. So stay with me and watch to the end. It's going to be very, very insightful. Now, when we talk about differentiation, our interest is to find the instantaneous rate of change of a function within its domain. So, differentiation is about obtaining derivatives of a function. This curve here is changing in slope everywhere. So as you move from one point to the other point, the slope is changing. For instance, over this portion, the slope stays positive. But when we come to this side, the slope stays negative. So how can we find the slope of this curve at a particular point? And that is what we are interested in. And that is the derivative we are talking of. So to be able to find the slope of this curve at a particular point, we need what we call the tangent. This is because when you have a straight line that is tangential to that point, the slope of that straight line is the same as the slope of the curve at that point. So this is where the analysis starts. We have this straight line which is tangential to our curve at this point. So this is a point of tangency. So when we are able to work out the slope of this straight line, we get the slope of the curve at this point of tangency. But what we see now is not easy to work out the slopes. So we're going to do some simulation to be able to approximate that slope that we are interested in at this point. What I'm going to do is that I'm going to shift this straight line parallel inside of the curve. And the moment I do that, it will meet the curve at two different points. So as we see, when we shift in, it meets the curve at two separate points. So we have this point and that point. But how do we know that this straight line is going to be tangential to this point of interest? Later, we will see how we will do that. But for now, let's try to talk about the slope of this straight line that we are so much interested in. We have coordinates of x here and we have coordinates of y. We have to understand that x is a given number. So x1 is a given number and x2 is a given number. Because x1 and x2 are numbers, when we take the difference, our resultant answer will be a number, and let's denote that number by h. So what we are saying is that h is a number because it's the difference of two numbers. So we are saying that h is equal to x2 minus x1. I can do rearrangement of the first part to get h plus x1 equals x2. And finally, I can say that x2 is equal to x1 plus h. Let's keep this in mind. because as we proceed, we are going to substitute in x2 with this relation. Now, we want to talk about y. y1 is a function of x1. Let's keep in mind y1 is equal to f of x1. In the same way, y2 is a function of x2, which we write as this mathematically. But as we saw earlier, we said x2 is the same as x1 plus h. So now our y2 is f of x1 plus h. Let's keep this also in mind. Okay, we have y2. So let's now proceed to take the difference between y2 and y1. We want to take the difference between y2 and y1. y2 is this and y1 is this. So y2 minus y1 is going to give us f of x1 plus h minus f of x1. Now, let's also try to write this down because we are going to use it. We are aware that the slope of a straight line is equal to y2 minus y1 divided by x2 minus x1. We have seen that this is the same as what? F of x plus h minus f of x. And this difference is h. So as we saw earlier, this difference is given by what is here. And this difference is given by h. So in our studies today, when we want to find the slope of a straight line, this is the formula that we are going to use. Let's keep it in mind so you can write it somewhere. Now, before we come to the formula, we want to observe something. As I asked earlier, how can we be sure that this straight line is actually going to be tangential to this particular point that we are interested in? As it stands now, we cannot tell whether it will be tangential or not. So we are going to do some simulation and see what happens. All that we have to do is that we have to push this line backwards gradually to see whether when it gets to this point, it will be tangential. But as we do that, I want you to make one observation, and this is the distance here, which is h. The difference between x2 and x1, which is h. Let's see what will happen as we try to push up the curve back until it becomes tangential to the point of interest. I'm going to push it, observe. So I have pushed it upwards a bit and I didn't change the slope, so I am pushing it in a parallel manner. Let's observe what happened. You see, the distance h is reducing. At first it was given by this distance, so the arrow will tell you where we were, and now it is closing up. I'm going to push it up again. So I'm pushing the straight line up again in a parallel manner. Oh, the distance between the two lines, which is h, is becoming smaller. I'm going to push it further. Now h is becoming small and small as we approach the point of tangency. You see, look at how h is. Let me push it up again. Oh, that is my h. Have you seen it? It is so small. Now, at this instance where we have seen h to be so small, we are now convinced that this line is actually a tangent to the point of interest. So this is where the catch is. This is where we are going to get our answers. We can convince ourselves that as h approaches 0, then we can see that the straight line is tangential to the point of interest, and therefore we can find the slope of that point using the slope of the tangent. So in differentiation, the first principle is that we can find the slope of a curve at a point by using the slope of the straight line that is tangent to that point, provided h is so small, provided h approaches 0, provided the limit of h is 0. So this is the first principle of differentiation. It is telling us that the derivative of the curve at the point we are interested in is the same as the slope of the straight line that is tangential to that point. We are going to apply this to solve questions. So we have restated again. By first principle of differentiation, the derivative dy dx is equal to the difference between f of x plus h and f of x, all divided by h as h approaches 0. Let's use this to find the derivative of this function. So we have a constant function y equals 3. Remember, this can be written as y equals 3x to the power 0 because any variable to the power 0 is 1. So this and that are the same. But I'm going to use this to solve. So what do? I need to apply the first principle of differentiation. I need my f of x, which is 3x to the power 0. And I need my f of x plus h, which is 3x plus h all to the power 0. Now I do substitution, so I have this and that all over h. Now remember, as we said, any number to the power 0 is 1. So this side reduces to 3 minus this side also reduces to 3. And when we take the subtraction, we are going to have 0 over h, which is equal to 0. So the derivative of y equals 3 is 0. Let's take this function, y equals 3x. We want to apply the first principle of differentiation. So we need f of x, which is 3x, and we need f of x plus h, which is 3x plus h. We do our substitution, and this is where we are. Let's open up the bracket, and we will get 3x plus 3h minus 3x. 3x will cancel themselves out, and we'll be left with 3h over h, and h will cancel h to give us 3. Therefore, y equals 3x. When we take the derivative with respect to x, we are going to get 3. Let's proceed to find the derivative of y equals 3x squared. We want to apply the first principle of differentiation. We need f of x, and this is 3x squared. We also need f of x plus h, and that is 3x plus h squared. We put into the formula, we have this. Now let's expand the bracket. So we are going to expand it with the square up here. So what do we get? We see that we will get x squared plus 2 times x times h, which is 2xh plus h squared. And we have our minus 3x over h. The next thing is that we have to open up the bracket with 3. So you get 3x squared plus 6xh plus 3h squared plus 3x squared. This and that are going to cancel out, and that will give us this. Now let's divide each term by h and see what we are going to get. So when we do that, when we divide each term by h, we are going to get 6x plus 3h. Now, this is where we are. Let's apply the limit. By applying the limit, we are saying that where we see h, we put 0 there. So we are going to put 0 here. And the moment we do that, this side is going to be 0. And our resultant answer is going to be 6x. So the derivative of y equals 3x squared with respect to x is 6x. Alright. Now we want to challenge ourselves. We have y equals x to the power n. What is its derivative? Remember, we are going to use the first principle of differentiation. Our f of x is what? X to the power n. And f of x plus h is x plus h all to the power n. Now we put it in the formula and we have what is seen. The question is, how do we expand this side? We can expand this side using binomial expansion. So by binomial expansion, this term here is going to be this summation, and this term is that. So binomial is saying that we can find a summation from k equals 0 to n of the combination of n combination k times x to the power n minus k times h to the power k. So when we are able to do this expansion, it's the same as the term here. Now let's do something first. Let's pick out the first term where k is equal to 0 and maintain the others. So we have this. We are going to pick out the first term where k equals 0 whilst maintaining the others. This is to say that wherever we see k, we put 0 there. Now remember, n combination 0, because k is now 0, is 1. X will be x, n is n, minus k, which is now 0, and that will give us x to the power n. When we come here, to be h to the power 0, and that will be 1. So the first term where k equals 0 is just x to the power n. So when we pick it out, we have x to the power n plus the summation, but this time k is 1 because we have taken out the term where k is 0. Now see something interesting. This and that will cancel out. And when that happens, we have this. Let's take out the first term again in this where k is 1. So we are putting k to 1. That means here we are going to have n combination 1, which is n. Then we will have x to the power n minus 1. Then we have k to the power 1. And that means you have n x to the power n minus 1 each. That is the term that is coming out. So when we pick that term out, now the summation will start from k equals 2. That is what we have now. Let's do this. Let's divide each term by h. So we are going to divide each term here by h. So when we divide this by h will go away and we'll be left with n x to the power n minus 1. Now here, when we divide it by k, what will happen is that k will reduce in power by 1 for every term in this summation. So this is what we are going to get. This side will be nx to the power n minus 1 plus all this. So this is where we are. Now, at this point, we are going to apply the limit. So by applying the limit, we are saying that we are going to put h to 0. So where we see h, we put 0 there. When we do that, we know this will be 0, 0. All this term is going to be 0. So that means that by taking the limit, this term will vanish and we'll be left with dy dx equals nx to the power n minus 1. So we are there. This is the power rule of differentiation. So we want to summarize what we have done so far. These are the functions and these are their derivatives with respect to x. So first we have 0. So remember that for every constant the derivative is 0. Then we have 3 here, we have 6x here, and in general we have n x to the power n minus 1. I'm going to take one example and work with the power rule. So we are given y equals 4x cubed. There is the power rule of differentiation. So we take the exponent to multiply what is there and we reduce the exponent by 1. By doing that, we have 3 times 4, which is 12. And when we reduce this by 1, we will get x squared. So when you multiply everything, you have 12x squared. And this is the derivative of the function up here with respect to x. Okay, this is where we will end the lesson for today. Where I was moving faster, please pause the video or repeat it to get the concepts clearly. Please, you can support me by subscribing, liking, and sharing my videos. Thank you for watching.